Oh, bonsoir à tous, merci d'être venus. Je veux prévenir, vu que je suis anglais, je vais faire le talk en anglais, mais je parle aussi un peu de français, donc n'hésite pas à poser les questions en français, et si je parle trop vite en anglais, n'hésite pas à me dire. Pour me présenter un peu, je vais faire l'introduction en français. Je suis développeur, je programme depuis une trentaine d'années maintenant. Je travaille actuellement dans le domaine de la géospatiale, c'est le web. Donc tout ce qui est carto web en open source, open layers, ce genre de choses. Donc je fais beaucoup de développement de JavaScript front-end. Mes projets actuels au boulot sont le 3D avec WebGL, donc Google Earth et Google Maps avec WebGL. Aujourd'hui, je vais vous parler des outils de Google Closure. C'est un univers d'outils qui sont sont fantastiques. Voilà, je suis patient en anglais. Okay, so Google's closure tools, there are many different parts to them. I'm going to focus on the compiler in this talk, and my goal in the talk is to convey to you as much detail, give you the experience to understand when to use it, when not to use it, the advantages and the disadvantages, what it can bring to you. It's part of a whole suite of tools. We'll go very quickly through the other parts there. And of course, everything's online as well. So first, the non-compiler stuff. This closure library. This is pretty much a standard library for JavaScript. It contains hundreds of thousands of lines of code to do pretty much whatever you want. Everything from graphics to unit testing to data structures to user interface components. Pretty much everything is there. I'm not going to go into it because it's far too much. Just say it is very high quality code. It's very modular. It copes with a lot of differences between browsers automatically. It's very well tested. There's a good active community behind it. And it's a really fantastic platform on which to build your JavaScript applications. There's also the style sheets and the templates. Now, all these tools are designed to work together. You can use them individually, but where they really come together is when you put them together. The style sheets, it's a CSS preprocessor, a bit like less CSS if you've seen that. With a few extra features. I'll show you a little bit just what it looks like. Is that reasonably readable? Yeah. This is an example of some Google Closure style sheets code. You get things like macro definitions here, which you can use later. You get conditionals. So this style sheet will be compiled into two different CSS files, one for mobile browsers, one for non-mobile browsers. You get effectively function calls, subroutines. Here's one called shadow. I pass some arguments, and this gets expanded out with different browser types. And then later, when I want to use these things, I just call them. So this allows you to do CSS at a high level. From this, it will generate real CSS that you then send to the browser. Here's an example of the output from the previous thing. Everything's been expanded. But what really gets interesting is that it can compress your CSS as well. This is also generated from the same file. Things you see here, it's very dense. You see the classes have been renamed. And I'll show you, oops. It generates a mapping here from classes in the original CSS to names. And all this is integrated together. So at the end, you get very compact CSS output. Fantastic for browsers with a higher level interface at the start. So that's what I say about style sheets. You can ask questions at the end if you want. Templates. There's a templating system. On its own, it's nothing particularly special. If you use Mustache or other sorts of things, you'll be very familiar with how these things work. What's interesting about the Google's closure style sheets is that you can use them on both the server side and the client side. You generate JavaScript functions which return large strings effectively for the client, and also, I haven't used it, but you can generate Java code which allows you to run the same stuff on the server. So for example, if you're in the case where you want to generate fragments of HTML on the server, send them to the client, and then display them on the client, you can use the same templates both sides. It's part of the integrated set, so it integrates very well with the class renaming. Of course, if we go back to our compressed CSS there, if we do any selectors by class name, we need to cope with that in our code as well. Google Closure, the integrated tools make it easy. That's all I'm going to say about style sheets. There's a linter. I assume you all use JSLint already. It's more of the same. It catches, obviously, the common sources of error. And if you want, it can also enforce a coding style, Google's coding style. I use it in all my projects. The actual linter itself is written in Python, and so it executes quickly. And I have, as part of my build process, I run the lint on all my JavaScript code. It's a very quick test, and it catches a lot of bugs early. The compiler. Now this is the main focus of the talk, and this is really the interesting part. This is what brings all these components together. We all know that JavaScript is an interpreted language. So what does the compiler do? Well, as it's written on the slide, it compiles the JavaScript to smaller and faster JavaScript. What this means is the output of it is JavaScript, but it's not really readable by humans. It's a single JavaScript file, typically, which contains all or everything that you threw at it. So you might throw 100 or 1,000 files at it. It will do whole program optimization and generate a single compressed file as output. Of course, there's a minimizer in there. The output is much, much smaller. There's an optimizer, which I'll show you some of the things that it does. It's really very cool technology, and it's designed to be used with the Google Closure library. You can use it on its own, but you'll only get a small part of all the benefits that it can bring. This, apart from the final slide, is probably the most important slide of the talk. Why compile? There's a real conflict in JavaScript. On one side, we as humans, when we write code, we want clear code written for humans. It's clear what it does, it's well structured, it's got hooks in it, it's got debugging code in there, it's got logging in there. This code is generally large because you've got all these debugging statements, all these comments, which is not what you want to send to the computer and send over the web. Over the web, you want your code to be as small as possible. You want it to run as fast as possible. And basically you just want to get rid of everything you don't need. So we have this conflict in JavaScript that it's between what humans want or what computers want are very different. And where the compiler really comes into its own is it allows you to write good code for humans and also get good code for computers out of it. So this is why really you should use it. But now I'll go into a bit more technical detail and show how it works, what it does. So the optimization, we're all used to using minifiers on our JavaScript. There are lots of them to choose from. This is to address these problems of size. The closure compiler does all these things. The third point, correct, is important. It doesn't change the functionality of your code, or it shouldn't. If it does, it's a bug, and I haven't found any bugs in the compiler yet. So it's solid code is what I want to say here. It's the compiler does work. It's predictable. If it doesn't work, it's probably your fault. The code it generates, they've gone beyond just generating the smallest possible output file, but they've also designed the output so that it compresses well with gzip. And a key part of the optimization is that it removes dead code. This means stuff which cannot be called is not included in the end, in the final output. This is a fundamental difference between what the Clojure compiler does and what most JavaScript minifiers do. The Clojure compiler analyzes your code, it works out what code is reachable and what is not. And you'll see that this, as well as making the output much smaller, has some very important benefits when it comes to modules and large code bases. It has 3 different levels of compilation. There is white space only is obvious. Simple optimizations, they'll get you to about 1.5 times the size, or it'll compress by a factor of 1.5. This is more akin to a traditional JavaScript compressor. It will do some variable renaming. The simple optimizations is useful as a first step, and it's also more compatible with existing JavaScript. I'll go a bit more into the limitations later. But where it really shines is advanced optimizations. These figures here, by the way, for 1.5 times gzip for simple, 8 times gzip for advanced optimizations. I can't remember which. It was some classic JavaScript library that I ran these tests on. In fact, often you'll see better compression than this. It's almost, what you feed the compiler is almost a different language. What I'll do is I'll show you a quick example of what the code looks like, and then I'll explain a little bit what it does. So this is, I'll just make it a bit easier to read. Is that reasonable? Yeah. Okay. We have a module system with these magic goods provide and require. There is a class object-oriented system. We mark up things with Java doc style comments, and these comments are interpreted by the compiler. Here's constructor for an object. Here's an example of a private member variable. We have constants, etc., etc. So this is what JavaScript written in the Clojure style typically looks like. The compiler itself, the language, you can think of them as language extensions. These are some of the things that it provides. So you've seen the JS doc style tags in the comments. You get strict static type checking if you want. This means that if you declare that your function the parameters should be numbers, then the compiler will warn you if anywhere it looks like you might be calling it with a string or any other variable. This, people who are familiar with Java and statically compiled languages will already know the advantages that this brings. In practice, in JavaScript development, this means that you can catch a lot of bugs much earlier than otherwise. A very good example of this is that when you're refactoring your code, often you will modify a function, and you need to make sure that where that function is called is also updated for the modifications. As JavaScript is interpreted, typically you won't catch that until your JavaScript runs. Whereas the compiler, doing its static analysis, when you do the compile step, it will warn you if you've missed something. It provides classical style inheritance, very much in the style of C++ or Java. You'll know that JavaScript is a prototype language. There are lots of different, well, at least 2 classical models, or 2 different models for inheritance. This uses the pseudo-classical style. You get accesses, public, private, protected, like in C++ and Java. These are, I wouldn't say enforced by the compiler, but you get warnings if you break them. And the compiler will also use this information to optimize your code better. Constants, type defs, and enums. Constant, you can say you can have nice human readable code. And for example, here. And then when you use it, the compiler knows that that value is constant and will substitute the value in. It's fantastic for configuration. It's used for enabling and disabling debug code, and so on. Type defs and enums, these allow you to, you have type defs and enums that you can use to, once again, write, it's used when you, rather than having to worry about, sorry, I'll rephrase that. In JavaScript, typically if you want a variable to take just one of a few values, you might assign a short string to it. If you make an error in that string, your program won't work correctly, although you won't find out until you run it or test it. By using type defs and enums, you can say this variable has only these limited set of values, and the compiler will spot if you use any other. There's the equivalent of pretty much the C preprocessor. For those of you who've programmed in C, you get hash defines, if defs, this sort of stuff. You can use it exactly the same way. This is great for enabling or disabling entire sections of code. One example is debugging code. Another example is if you want to use the same code base but generate different desktop or mobile versions, or for versions for specific browsers, for example, you can use the same set of code base and use these if defs effectively to get custom builds for each platform. Up to this point, the things I've mentioned are in the comments, and they're effectively extension. Well, they tell the compiler a bit more about what you want to do with your JavaScript to do. However, that doesn't go all the way. There's a base part of the closure library called goog.base, and this is really core functions like inheriting from one class to another, calling an ancestor's class, etc. These sort of things. These get special treatment by the compiler. What this means is if you use the compiler outside, without the library, you won't get the full benefits. There are some limitations. The compiler works out what code is reachable. It cannot look inside calls to eval, so you don't get to use it. And that's, for any of you with a computer science background, you'll understand exactly why that is. I'll show you now a little bit of the just so you output. So we've seen what the CSS has done. Sorry, let's go another one. Here we are. No, not that one. Sorry, it's in the browser actually. This is what compiler output looks like. It's pretty unreadable. This is an example from one of my WebGL projects. One of the key things that the compiler does is it renames everything to use shorter names. In fact, it does a lot more than that, but this renaming means that that you have to write your JavaScript knowing this. What the compiler does is anytime it sees object.property, it can replace either side of this. This means if you mix up different ways of accessing objects in JavaScript, here I'm using it, a sort of, I'm not sure what you call that reference. I'm passing a string here on the right-hand side of the equal sign, but using the dot notation on the left. When it's compiled, this will not work. So you need to be aware of this in your JavaScript when you write your JavaScript code. Similarly, if you want your compiled JavaScript to be usable by others, if everything's renamed, they're not going to get an API that's usable. So you need to tell the compiler if you want other people to use your code, or if you're writing a library and you want other people to use your code, then you need to tell it what not to mangle, effectively, what not to change. And similarly, it will try to rewrite everything. So if you're using a third-party library, you need to tell it that these things coming from a third party and should not be renamed. In practice, this is much less of a problem. There are files already that allow you to use jQuery, Google Maps, many of the larger JavaScript libraries. These things are already done for you. And if not, they're relatively easy to write yourself. The compiler provides a module system. Those of you who came to the first JavaScript Geneva talk will remember that we looked at require.js, which was common.js, which was a proposal for a module system for JavaScript. The closure tools provide this already, and in my opinion, in a better way. This is how web applications like Google Maps and Gmail and Google Docs are written. They have code bases with millions of lines of JavaScript separated into modules and good module systems to manage all that. Modules are fairly straightforward. In Google Closure, you declare what your code provides, you declare what it requires, and you throw everything at a build script, which then generates just what you need. I mentioned earlier that the compiler will eliminate code which is not called. This means that when you throw everything at the compiler, you effectively get a custom build of just the code you need. You no longer have to worry about manually making sure all your requires work. I mean, as long as you get the basic stuff right, the compiler does everything else for you. If you use a module, but you only use some function, a subset of the functions from that module, the compiler will only include those functions that you actually use. So this replaces your build, well, this is a very powerful part of your build system. Those of you who've used jQuery or OpenLayers will know that these third-party JavaScript libraries typically come with a tool that allows you to do a custom build, so you can choose the bits that you want to avoid having a very large output file to send to the browser. Google's Closure compiler does that for you automatically. You just get that for free. I'll just show you. I won't do that yet. Okay. How do you use it? There are two different modes: uncompiled and compiled. The way that the tool is designed, you can use it everything uncompiled, which is fantastic for debugging. It's very easy. Obviously, it's a bit slower to run in your browser, but you can do all your debugging in the normal human readable code. You put 3 script tags in your JavaScript. You load the base library with the first line. Deps.js I'll explain in a second, and then finally you call goog.require, which then loads that your root module, if you like. Deps.js basically tells goog.require where to find the dependencies. It's as simple as that. I'll show you a quick example, just to make it all clear. Deps.js. Here's an example from a toy project, and this says very simply, when you load this file, you need to load. Sorry, I'll rephrase that. This file provides this, and it requires these. And it will recursively do the lookup for you. So in your code, all you write is the base, include the deps, and then goog.require does the rest for you. This is really good for debugging. It just works. In compiled mode, it's a bit different. Remember, the output of the Clojure compiler is a single JavaScript file. Typically, you include that just directly, well, you include it with a script tag or even directly in line with your HTML. You need to tell it where to start, the equivalent of this goo.require, where do I start? That's passed as a command line to the compiler. This generates your huge file, which looks like this. And there you go. The compiled mode is quite hard to debug. Even if you know the compiler will restructure your code quite extensively. I'll show you an example of that shortly. There is a Firebug extension which will allow you to have a better visibility as to the correspondence between the compiled code and your original code. In practice, well, I've never used it and I've never had to use it. When the compiled code has behaved differently to what I expected, it's always been because I've made this mistake here. So very quickly, although the compiled code is difficult to debug, you very rarely actually have to do it. Okay. Where do things go wrong? Name mangling, all this renaming. You need to be a bit careful about it. It does become natural, but it does take some time to learn as well. Basically, you just have to be very careful when you write your JavaScript code that you're consistent in the way you access your objects. The compiler does strict type checking, but JavaScript is a dynamic language. What this means is that some things which are commonly used in JavaScript are difficult to express to the compiler. A classic example of that is where you pass a JavaScript object containing lots of different options, which may be present or not. These are often used for configuring objects. Expressing the type of such an object, which has lots of properties which might or might not be present, isn't particularly easy. So sometimes that's a bit of a problem. The differences between compiled and uncompiled code, when they happen, it's because you've made a mistake. They can be sometimes quite hard to track down. Those of you who've used jQuery are used to document.ready. There is no such thing in Google Clojure. This is actually by design. The problem with document.ready is that the browser has to load the entire page before it runs your ready function. You get higher performance if you can run your JavaScript as soon as everything is present, basically. So by deliberately haven't chosen that. This means that the way you initialize your application is a bit different. And finally, some JavaScript libraries try to be really, really clever. And these just simply will never work with Google Clojure. A classic example is Touch or any of the Ext-based libraries. In these libraries, they have their own class systems. When you declare that an object has a property, X, the library will generate a getX function, a setX function, and lots of other functions for you. This relies on the names not changing. And basically, Ext will never be compatible with Google Clojure. That said, JavaScript libraries which aren't or don't try to be clever generally do work with it. I'll show you a little bit of demonstration now, then I'll summarize with the practical experience sign. And what I want to do is to show you, go into a bit more of the code. So this is, I'll just make it a bit bigger. Okay. So this is an HTML file. This runs Google Closure code in non-compiled mode, or uncompiled. We've got the 3 script tags I mentioned. Then instead of document.ready, in the body, I've got a script, another script tag, which will call my main function, which is defined in this module. Here is that module. I declare that it provides this functionality, that it requires 2 other libraries, 2 other modules. I have a define, which is like C preprocessor, for those of you who know C. Notice it's got a type. And here I declare my function. This is then fairly classic JavaScript. And this runs pretty much as you expect. So it will create an incrementer object, which just adds 1 to things. In this case, it will add 1. And when we run that code, it's very trivial. We'll just compiled. It will 1 + 1 = 2. To note at the end, there is a little goog.export symbol. This says, whatever you do to, however you compile the rest of the code, I need toy.main to be available, toy.main to be available outside. And if you remember, that's what we call when we call our code. Here is a fairly trivial class. Once again, we find it's a module. Goog.array is array functions from the closure library. This constructor tag means that, well, it tells the compiler that this is creating an object, and the compiler will warn us if we ever forget to call new. I'll demonstrate that, in fact. So I just let's run the main. Let's give another one here. Sorry, this is just building it. So this is just doing this is doing it without errors. If I main.js, if I forget the new in the function, when the compiler runs, it will give us a warning here. It's spotted. We declared this as being a constructor, and it warns us basically. In fact, if we forget the new value, incrementer will this will return the value undefined, and we get a second warning that then this object, which is now undefined, has no property called increment. I'll show you that's here. So you can see that the compiler is doing reasonably sophisticated analysis of your Java code. It's spotted a classic error, and we put it back. I'll just let that run in the background, so we can fix that. Yep.
Sorry, I'm not sure I understand. What is the object toy?
So the object.
Or like the variable toy?
Toy. Oh, sorry, it's the name of the project. Okay. Yes. It's a good question. So when I call goog.provide, it automatically creates toy, which is an object, and in this case, in fact, it just creates the toy namespace or toy object, and then here I define a property on it. So it comes from the actual variable is instantiated by goog.provide. Well spotted. Yeah. Okay. Here are some this is now fairly classical JavaScript. We defined functions on the prototype. We get to define. We define how it should be called, what should be returned. We can provide quite complex types. Here is we're saying that this increment each function should take an array of numbers, and we'll get a warning if we provide array of something else or anything undefined, and equally it returns an array of numbers. And here we call, and to actually do this, we're using goog.array.map, which just applies this function to each element in the array. So I'll show you a little what this comes out as now. So you've seen the human readable code. This is what it looks like when it's compiled. I'll load that into something with a bit of syntax highlighting. So the red underlining is because I have JSLint automatically running in my debugger, sorry, my editor. So what we see here is a lot more code than we initially wrote. It's because I've turned I'm using simple optimization, sorry. I was playing around with my demo earlier. I'll just redo that. Let's go put the optimization up to advanced. This will be more sensible. So I rebuild that, and we'll just in the simple optimizations there. Let's ignore at this point. This is an output with simple optimizations. What we get is classically minified JavaScript and no dead code elimination. If we reload the file, this is more like it. This is now the output of the compiler with classic, with advanced optimizations. This function here actually comes from the closure library. It's the only function we've used from the closure library. So the rest of the closure library isn't there. We've got a custom build of the closure library. In here, we can see, so what I should do actually, I'll put these side by side actually. Let's do 20. So I'll show you some of the optimizations that have happened. So here we're creating a new incrementer object with passing the value 1. The actual code is here. So all that has become new I. It's renamed the classes. You'll notice that here we have 2 levels, toy.incrementer. This has become a single high-level object, I. So it's compressed all that hierarchy of objects into a single one, which avoids lookup, so it's going to run faster. The incrementing is the 1 value here, which came from a constant, has been brought in. We call, get this right. Later on, we call this goog string format, which is the same as printf or sprintf. And what's happened here is that this is now a function called e, which is the one defined up here, which came from, there's the e. This came from the closure library. And then finally, so this is all assigned to a variable a. Here's the assignation here, which is what was message on this side is now called a over here. And then finally, our alert is called at the end. So you can, what you've seen here is the compiler's being really clever. It's compressing objects, it's specializing them, and you get a level of JavaScript compression out at the end, which is way beyond what you can get with a normal minifier. At the end, incidentally, this goog.export symbol is actually done with this bit of code here. And I haven't looked into the details, but it works out, it assigns the right value to toy.main so that, oops, let's do that again vertically, whoops. One, two, six. Okay, which is, well, the toy.main is what we need in our HTML. To show you it doing even more, so here we have a define called use.string format. Instead of using the string format function in JavaScript, we can just add our number to a string. We don't need this heavy function. So I'm going to set this to false. So now instead of the first branch of the if statement being executed, it's going to be the second branch. I'll run the make again. Load new file. This is now our code minimized. It's even shorter. There is no extra code from the closure library because we don't call any functions. And in fact, it's just got very, very small. Inside now, instead of calling it alert with a variable, it is actually computed directly inside the call to alert. So I think this is a reasonably good demonstration of just how much more the compiler is doing than the standard stuff. There is this little toy project is on GitHub. If you clone it, it's on my GitHub repository. If you clone it, run make, it will get all the dependencies and you can play around with it. And it's a really minimal example. There's a README. I'll show you. It's on here. There's a README and it gives you a couple ideas to try playing around with. So you can try changing one thing at a time. As practical experience, I use it now. I was first introduced to Clojure Compiler about a year ago when I worked on an open source project called WebGL Earth. Since then, I've become a complete convert. I use it in all my projects. To show you what it's doing in real life for me, this is, I'll show you this is I'll show you the demo first. This is a web mapping application. These tiles are coming from the Open Web Server, but this is using WebGL, so you get to do some funny things with it. Let's go. What am I doing here? Anyway, so this is all written in JavaScript, doing mappy stuff. Just stop that. Now, the code there. This is my human readable code. Each of these files contains a class. In total, there's close on 300 kilobytes of code there. When it's all compiled, I get just under 40K. So it's made a really big difference. What I also do is that I have my debug version where the source code is very standard with the 3 lines of script there, as standard. But then in the version that I give to clients, if you like, I put everything in line. So now my JavaScript is directly in line with the HTML. And this means that when people download my application, they download a single HTML file which contains everything. So it's super quick. So practical experience of it. There's quite a lot of text on this slide. I'll explain them. So the Clojure tools, they solve a lot of classic problems in JavaScript. Things like modules, custom builds, detecting problems early with your code, flexibility, having different builds, using third-party libraries. It finds that with this, I find I can catch bugs a lot earlier than when I'm writing normal non-compiled JavaScript. If you don't have a compiler, you'll end up relying on testing, basically, to make sure your JavaScript works. The compiler won't catch everything, but it catches a lot. And that allows me to work a lot faster. The tools, they're not really, you can use them on their own, but they're not brilliant. They work much better as a whole. We have the closure library with the compiler and the templates doing your renaming, etc., etc. The classic criticism of compiled code is that it's hard to debug. In practice, this is not so much a problem. You will get confused when you first start using it, but you'll learn not to make the mistakes, and it very quickly becomes natural. Debugging is actually not a problem. And in the closure libraries, there is also really good support for debugging. There's loggers, there's things that check exceptions. A classic example I'll show you actually. Just one of the things that has really sped up my development. Maps. Let's go. I think this has a search. No, sorry, I just need to check. So, this is some WebGL code. Doesn't matter. But what I have here, this is using a call from the closure library, a thing called asserts. You're used to these if you've written any C. So this is code which asserts that the statement inside is in fact true. So I'm asserting that this value is not null. In my debug version, my code is full of these asserts, and it means that if I've made a mistake somewhere, I can catch it really early. But in the compiled version, these asserts are stripped out, so they're not extra weight. They don't slow down my code. So this on its own is just a revelation with JavaScript. Overall, I mean, it makes JavaScript much more like Java. This can be a good thing and a bad thing, depending on what your opinion of Java is. It's certainly, for writing big projects, it's really useful because you can really well modularize your code. You can define accesses, private, public, protected, all this sort of stuff. It makes a really big difference on big projects. On small projects, the feedback is, well, the advantages are less, but still there. With becoming more like Java, you get this extra checking, this extra security that Java provides, but you lose some of the flexibility that JavaScript provides. So some of the magic that you're used to do, you might expect to do with JavaScript, creating functions with certain names on the fly, are harder to do with the closure compiler. So it's almost better to think of closure compiled JavaScript as being a slightly different language to normal JavaScript. If you want to use the advanced optimizations, you will need to refactor your project somewhat. It's unlikely that your code that you have at the moment will be compiled perfectly with advanced optimizations. It might find problems in your code. What's for sure is that you won't have all this markup type stuff, and so the compiler won't know about your code in full detail. You will probably need to do some refactoring. As it's a whole program optimizer, it can sometimes be slow. If you're bringing in large parts of the closure library, if you've got a big project yourself, this is a reasonably nice Mac with an SSD disk. Compiling is a few seconds. When I run it on my netbook, it can take, on a big project, it can easily take 1.5 minutes. So this can slow you down if you want to get the compiler to be checking your code all the time. But remember, you can also run in debug mode where there's no compiler, and therefore it's not too bad. There are some tools, I haven't used them. I think Plover is, I'll just check that actually. I think it's called Plover. I haven't used this. But this is basically something that runs in the background, always building your code, and it avoids all the slowness, basically, just happens in the background. I haven't used it, so I can't say how good or bad it is. Once you're building your JavaScript this way, it's a fairly complicated process. You've got to build debug builds, deps.js, you've got to build your compiled stuff. If you're also involving the CSS, the style sheets and the CSS compressor, all this needs to be put together in the right order. So you do need a reasonable build system to do that. I think Plover does it. Personally, I'm using Make, but that's just that's what I know. If you're using external packages, if you want to use backbone.js, for example, with Clojure, then you'll probably have to write a little file to explain to Clojure how to treat Backbone. This can be quite annoying at times. The best world, if you like, is when all your code is in Clojure, and that way it just does everything and you don't have to worry about it. But that's obviously not always possible. And finally, it's the compiled code that you get out at the end is not particularly, sorry, find the right one, is not particularly human readable. This can be an advantage if you're working on a project where you don't want people to be able to read your JavaScript. They of course still get the JavaScript, but it's harder for them to understand what it does. And what they certainly don't get is the code in a form that's friendly to be modified. This has been very useful. Although my job is open source development, sometimes on new projects we want to send a demo to somebody and you want them just to be able to use the demo but not see all the magic that you put in behind it. And if you're working in a commercial environment, it's not a layer of security, but it will certainly slow down and or protect, a little bit of protection for your code. So that's my practical experience of it. That's pretty much the end of my talk at this stage. So I'll happily take questions.
Yes.
Yes.
Is it possible to make with a test unit?
Yes, I might even have an example actually. So built in the Clojure library, there is, I'll show you the docs actually. Here, I don't have it. There is a, sorry, I can't type, too many people watching. Library. There is a unit testing framework based on JUnit. Oh, great. They have just changed it. Oh, great. The documentation is not bad, by the way. I'll just find the. Okay, I'll look at the code actually. Let's go here. I think I have. Yes. Okay. So there is a unit testing framework in there. I'll show you what it looks like. Is it possible to open a window? Wait, could you just let some cool air in? Oh, good, yes. Google testing. So the testing is generally done in, you write an HTML file, you get your standard set up, tear down stuff. Any function that begins with test will be automatically run. It's basically JUnit. You end up with something that runs like this. JavaScript console. Let's go to scripts. And you get all your code in debug mode where you see the individual files. So you can set breakpoints, run that reloading, and debug as you wish. So yes, there is there's testing in there. Just a point on that. So I believe that Google effectively forked JSUnit about 3 or 4 years ago. At the time, it was probably the best testing framework around, but I think other frameworks are probably now a bit better. But it's been sufficient for my needs. Yeah. Cool. Les autres questions en français aussi, ça. Oui, oui. Donc je vous donne un exemple de ça. Let's go here. Closure, compiler. Sorry. Externs. Qu'est-ce qu'il y a? Je vais prendre ce que j'ai query. OK. Dans le cas où tu as une bibliothèque externe, en gros, il faut que tu crées un fichier externe qui explique quelles sont les fonctions là-dedans. Ceci, c'est un exemple pour les fonctionnalités HTML5. En gros, il n'y a pas de code, c'est plutôt quelques lignes avec les types associés. Donc, un élément Canva qui est assez prototype, certaines fonctions avec leurs paramètres. Donc, si tu utilises Backbone, il faut créer la même chose, mais pour Backbone.
Si on ne fait pas ça, ça ne marche pas ou bien c'est moins efficace?
Tu as 2 options. Tu peux envoyer Backbone avec tout ton code au compilateur et ça se peut que ça marche. Il faut tester avec la bibliothèque. Mais par contre, sans ces informations sur les paramètres, le compilateur ne saura pas quels sont les types il faut envoyer. Donc, il va probablement compiler ton code, mais par contre, tu n'auras pas tous les tests ou tous les checks que le compilateur fait. Donc, je ne peux pas vous donner une explication exacte pour Backbone, il faut simplement tester. J'ai regardé le code de Backbone, c'est une super bibliothèque, c'est très très bien écrit. En le lisant, je pense qu'avec Backbone, ça devrait fonctionner. C'est bien propre, ça devrait marcher. La seule chose où il faut faire un tout petit peu d'attention, c'est dans le classique. Backbone utilise toujours cette façon d'accéder les propriétés des objets. Et c'est consistant, donc ça devrait marcher. Par contre, dans ton code à toi, il faut que, vu que ce sont des chaînes qui ne vont pas être renommées, il faut que toi aussi utilises le même moyen d'accéder. Mais je pense qu'avec Backbone, ça devrait fonctionner. Cool.
Il y a plein de librairies aussi qui créent des fonctions runtime qui posent des problèmes, ça fait rare. Genre des librairies qui prennent un tableau de string pour créer une série de fonctions. Il y a tout un problème de matching avec les noms compilés.
Oui.
Genre jQuery, c'était ça.
Oui. Donc, en gros, en closure, le moyen de le faire, c'est. Le moyen de changer le prototype, c'est plutôt faire chaque fonction explicitement. Dans le cas où tu fais extend et puis tu passes un objet avec avec une liste de propriétés, ça devrait marcher.
Moi, j'ai connu qu'ils avaient souvent le each avec une liste de strings, puis ils créent tous les accessoires pour des offset x, y, etc. Et à l'époque, je ne sais pas comment c'est maintenant, mais je sais que ça passait pas sous le compilateur.
Ok. C'est dans quel projet? Tu as un exemple?
C'était dans jQuery il y a genre 1 an en arrière.
Ok.
Quand on passait en compilation, maintenant peut-être ça passe. Mais à l'époque,
Oui.
ça passait pas.
Oui.
Parce qu'après, il y avait des références de ces fonctions dans le code, etc. Et,
Oui.
vu qu'il avait remplacé en fait les noms dans le code et qu'elles ont été générées au runtime, ça.
Oui. Si ces properties sont. S'il faut qu'ils gardent le nom pour utiliser en tant qu'externe, par exemple, si tu compiles la bibliothèque jQuery pour l'utiliser ailleurs, c'est sûr que ça ne va pas fonctionner si le compilateur renomme ces properties-là. Par contre, si tu compiles jQuery avec ton appli, tu envoies le tout à Google Closure, il va faire le renommage, mais ça va être consistant en interne, donc ça devrait fonctionner. Je pensais qu'il avait... juste que je teste. C'est peut-être... Oui. Donc, il a déjà proposé créer le fichier externe qu'il faut. Ouais. Okay.
Comment on fait pour travailler sur les classes CSS, étant donné que les classes ont leur nom qui est changé?
Bonne question. Je te donne un exemple d'un projet. En fait, je vais faire un checkout. Donc ici, on va voir dans les templates. Bon, c'est un exemple des templates closure. Je suis pas allé en détail tout à l'heure. Je prends un exemple simple. Voilà. OK, un tout petit template qui est juste un élément input. Là, ça c'est goToInput, c'est le nom de la classe que je veux. Je le mets dans ces brackets-là. Ça force le compilateur à en fait chercher dans le table de renomenclature, je sais pas, j'arrive pas. Renaming table, voilà. Donc ça il le gère lui-même. Quand tu veux contrôle JS, CSS name. Quand tu as besoin d'une classe, il faut, au lieu de passer la classe, tu appelles cette fonction google.getCSSName qui va rechercher dans le qui va chercher dans le table et retourner la bonne valeur. Et juste pour vous montrer ce que c'est dans je cherche juste un exemple. OK. Ici, en fait, on est dans une template. Et là, je montrerai le code d'origine. OK, donc le select ici, là j'ai passé le nom de la classe en CSS, et en fait, dans la version compilée, il est là, et il a déjà fait le renaming là. Okay. Au-dessus dans le système de templatage, il aussi utilise des moyens pour concaténer les chaînes en fonction du browser. Donc, il y a certaines choses qui sont très rapides avec WebKit, qui ne sont pas très rapides avec Internet Explorer. Donc, en fonction du browser, il utilise le bon système, le système le plus rapide. Mais ça se fait par la bibliothèque et le compilateur. C'est pas, donc, tu peux oublier ça, tu peux focaliser sur ton appli. Cool, ben, merci bien.